In this video, we present new techniques for interactive public ambient displays. Conventional information sources such as bulletin boards are common in high-traffic locations like an office building or university concourse. We've developed a new type of information source, which is a queryable ambient display incorporating peripheral notification, implicit and explicit interaction. Our research concentrates on fluid movement between different interaction modes, techniques for supporting multiple users, subtle notification, privacy controls, and self-revealing help. We built our prototype using a touch-enabled 50-inch plasma display and Vicon real-time motion capture system. This gave us a flexible range of input sources from the user's body, head, hand, and fingers. We anticipate that as computer vision techniques become more robust, cheap cameras will be able to do similar tracking without requiring any markers. A central characteristic of our system is the ambient display of 4 information sources, each represented as a horizontal stripe spanning the width of the screen. In our prototype, we show information suitable for a hypothetical office environment: current weather, activity levels in branch offices, an event calendar, and messaging. For interaction, we use both implicit contextual cues such as body orientation and position, and explicit actions such as gestures and touch input. For example, as a user approaches the screen, the ambient display reveals more detail. This behavior, which is based on the location and orientation of the user's body, introduces the 4 primary interaction phases: peripheral ambient display, notification with ambient interaction, personalized subtle interaction, and private interaction. When a user enters the space near the display, their body location and orientation is translated into viscous but responsive relative movement in a vertical bar. This type of movement keeps the display functioning on the user's periphery until they initiate an explicit action. Where the user's vertical bar intersects with each horizontal display, a notification flag subtly conveys the current level of importance of that information to that user. As an item becomes more urgent, the color saturation, opacity, and size of the flag increases. Also, an urgent notification flag's movement moves more out of phase with the bar to increase visibility in the user's peripheral vision. By facing the screen and stopping for a moment, the bar widens and additional details presented for each notification flag. Also, some ambient displays augment their public information with the user's own personal information, like in the calendar and messaging displays. When the user walks away, the bar returns again to the subtle notification mode. To facilitate casual, fast interaction from a distance, selection of an information source is accomplished using simple hand gestures. To promote walk-up and use simplicity, the system features self-revealing help. After a certain length of time in which a new user does nothing, a help mode initiates demonstrating how to select information using a simple hand gesture. In this case, an open hand pointed out with palm facing down. The user regains control of the interface again by initiating the instructed gesture. All gestures used in the system feature on-screen visual feedback with subtle reminders of available actions. Moving the hand slowly up and down highlights an information source, and a quick down flick selects. After an information source is selected, a detail panel is shown in the lower portion of the display. The detail panel provides a zoomed view combining both public and personal information together. Here you can see the user's personal events above the dashed line and public events below. A square in the information source above indicates the location where the detail information is retrieved from. The user can navigate the source information by either moving their body laterally to the portion of the display that interests them, or by using a reach gesture to move the selection source along the display. Similar to selection, an open outstretched hand is used, but this time with palm facing to the left. As before, hint icons remind how to cancel or complete the gesture. A quick downward flick selects the new location, while an upward flick cancels and returns to the previous position. The reach gesture allows selection beyond other users who may also be using the display. Stepping closer to the display allows information to be further queried using touchscreen input. For example, with the calendar, touching the event displays a full description. Note that privacy is afforded by the occlusion of the user's body. A lift-up gesture is used to return to the overview of information. To further preserve privacy, 2 intuitive gestures are used to hide and show the notification and querying modes. We now show a series of interactions on the display to show its various features working together.